Angle pairs. There are different types of names for different types of angle pairs. The one that is the most basic is adjacent angles. Adjacent angles are angles that share a common vertex. Basically, it means that they're next to each other. They're connected in some way. So on this one right here, angle ABC is adjacent to angle CBD because they have the common vertex B. Complementary angles are a pair of angles that add up to 90 degrees. Now for complementary angles, they can be connected, in which they make a 90-degree angle like this. 50 plus 40 is 90. But they don't have to be connected. These two are also complementary because 31 plus 59 degrees is also 90 degrees. Supplementary angles are a pair of angles that add up to 180 degrees. So on this one, these are on a line. A line is 180 degrees. So if you have two angles that make up a straight line, they are supplementary. 125 degrees plus 55 degrees is 180 degrees. Now again, they don't have to be connected. These two are supplementary because 42 degrees plus 138 degrees is also 180 degrees. Vertical angles. Two angles on opposite sides of crossing lines, and they are congruent. This is going to be a very useful one. So if you have two lines that cross, the angles on opposite sides are congruent. Now there's a couple pieces of notation in this picture, and there's a couple ways you can use this notation. If you have this little angle drawing in right now, and one line on both of these, that means that they are congruent. Those one line pieces show that they are the same angle. So those might both be 30 degrees. Then the other two have two lines to denote that those two are congruent. You can't use one line because that's already been used, so you move on to two lines. So for instance, if there was another set of angles in this picture that were congruent, they'd have three lines. Now another way to draw that is have different number of little arcs. So in this one, the single arcs are both 19 degrees. They're on opposite sides of two crossing lines. And this one with two arcs are vertical angles. They're on opposite sides, and they're both 161 degrees. Something I do want you to notice, that 91 plus 161 is 180 degrees because these two angles make up a straight line, so those are also supplementary. Now, a linear pair sounds like a fancy one for supplementary because there are two adjacent angles that form a line and add to 180. They add to 180, but they must form a line. So they are very specific ones. They can't be non-connected and add up to 180 degrees. They have to be on that line. So for this one, 128 degrees plus 52 degrees makes that line, and it's 180 degrees. Now, angle notation. So if I have this angle over here on the right, angles A, B, C, I use this little symbol right here. It kind of almost looks like a drawing of an angle, almost looks like a falling over L. That angle ABC is referring to the entire shape. So like the shape that I would draw to make ABC. Now, if I add an M in the front, this becomes the measure. The M is short for measure of angle ABC. That's referring to its size, its degree. So for this particular angle, the measure of angle ABC is 67 degrees. That is an acute, a 67 degrees angle. So when we start solving for angle measurements, you're going to see the notation of the measure of angle. That means that the answer is some sort of a degree. So if I look at this problem, one of the things that I notice is this little box in the corner, and that tells me that the entire thing is a 90-degree angle. That's a complementary set of angles. So that means that whatever 3x plus 11 is, because that's the degree of our first angle here, and whatever 2x plus 4 is, which is the degree of our second angle here, they must add up to 90 degrees because those two angles are complementary. They add up to 90. So if I were to solve this, I would first combine like terms. 5x plus 15 equals 90. Then I would subtract 15 from both sides. I would get 5x equals 75. I would divide both sides by 5, and I would get x equals 15, which is our first answer. What is x? Now to figure out the rest of them, the measure of ABC. So first of all, make sure you're looking at the correct angle. So if I were looking for the measure of angle ABC, I'm going to trace it. I'm going to trace it in the order that it's written. So from A to B to C is that top angle that is 3x plus 11. So if I were to make x 15, I'd go 3 times 15 plus 11. So 3 times 15 is 45, plus 11 is 56 degrees. Angle CBD. So again, I'm going to trace that just to make sure I'm finding the right angle. From C to B to D is that bottom angle. So I'm going to plug 15 into here. So 2 times 15 plus 4. 2 times 15 is 30, plus 4 is 34 degrees. Now double checking my answer, is 56 plus 34 90? Yes it is. That means I found my correct x and I've computed everything correctly. Okay, one more problem. These two angles are supplementary, or also known as a linear pair, because they are on a line. So that means that these two must add up to 180 degrees. So my equation is going to be 9x plus 8, which is my first angle, plus 5x plus 2, which is my second angle, equals 90 degrees. So I'm going to solve this. So 9x plus 5x is 14x, 8 plus 2 is 10, and that equals 90. Sorry, not 90, 180, my bad. Then I'm going to take 180 and I'm going to subtract 10 from both sides. And I'm going to get 170. And then if I divide both sides by 14, I'm going to get about 12.14. Now this one's a decimal, which is totally fine. So I'm going to go 12.14. And if I find the degrees of my missing angles, the measure of angle WXY would be this first angle on the left, so this one here, and I'm going to do 9 times 12.14 plus 8, so 9 times 12.14 plus 8, and I'm going to get 117.26 degrees. And then for my other angle, angle YXZ, that's going to be this angle over here. I'm going to do 5 times 12.14 plus 2. So 5 times 12.14 plus 2, and I'm going to get 62.7 degrees. So if I were to round this, this would probably be more of a 0.3, because 117.3 plus 62.7 gets me 180 degrees. So just rounding it correctly because it's a decimal, which is totally fine.